All right, so here are your 8.4 notes on logarithms and log functions. I'm expecting you to be able to evaluate and graph log functions. Not really graph them, but be able to evaluate them. All right, you have a warm-up. You can go ahead and do the warm-up, those two warm-up problems on your own. All right, and then I'll give you the answers to them later on. All right, but we're going to start right at the notes. All right, so some of the things that we do know is we know that 3 squared is equal to 9. We need to know that 3 to the third power equals 27. But 3 to what power gives us 18? What value does x have on that? All right, so they didn't know, and they didn't know how to do that. There is something. There is a number that's between 2 and 3, right? Because 9 and 27, 3 squared gives us 9, 3 to the third gives us 27. So between 2 and 3, there's a number that will give us 18. So what happened was the mathematicians developed these things are called logarithms. And logarithms are to solve problems like this so that we can find out what is the answer for this. So what they did is they found out that x, and if we do log 3 of 18, we get 2.631. And it turns out that 3 to the 2.3631 is approximately 18. All right. This actually goes on a little further for the answer. And when you're using the calculator, you can just plug it in and see. All right. But that should make sense that it's 2.6 because we said it had to be between 2 and 3 because 18 is between 9 and 27. All right. So what are these things called logs? All right. One of the common logs is log base 10. In fact, it's such a common log that you rarely ever see it written like this with this log base 10. All right, it's usually just written with the word log. All right, so anytime you see that word log, that means log base 10. All right, so whenever it's written by itself, it is log base 10. All right, so what are the things that you're going to have to be able to do? You're going to have to be able to rewrite these in different forms. So this is what it would look like in exponential form. All right, this is what the same thing would look like in log form. All right, so notice the base for the exponent is b. That b is also the base for the log. All right, so whenever we rewrite this into log form, the b that's here goes for the base. Same way if when we're taken out of this form, we put the b there. All right. All right. So the exponent, whatever you have as the exponent, that's going to go on the other side of the equal sign when you write it in log form. And what's on the other side of the equal sign goes after the log. All right. When you're rewriting it. All right. It should make sense when I do a couple for you. All right. So here we go. We're going to rewrite these in the different forms. All right, so we're going to take log base 2 of 16 is equal to 4. All right, so again, in exponential form, this is our base, so we write the 2. This is our exponent, so we put to the 4th power, and then we make it equals 16. All right, now we're going to take this one in exponential form, and we're going to rewrite it so it's in log form. So again, this is the base, all right, for our log. So it's going to be log base 7 of, all right, and that is where our exponent is, all right. So, or that's the number on the other side. So that's that 1, right? Where our 16, so this is the 1, equals, and then this is where our exponent goes. Okay? All right, we have log base 5 of 5, which is equal to 1. So again, here's our base. So that's the base. This would be our exponent. Then our equal sign, and this goes on the other side of the equal sign. All right, and these should be true. All right, 5 to the first power is 5. 2 to the 4th power is 16. So if your log statement's true, then this statement's going to be true. All right, so now we're going to rewrite this one in log form. So again, we got the word log. This is our base for the log, so it's base 10. All right, this is what we're taking the log of 0.01. And then this is what it's equal to, is our exponent. All right? And it should make sense because, again, if we would rewrite this, we would have the base of 10. This is our exponent. And then this is what it's equal to. All right? So the next one, we have log base 1/4 of 4 equals a negative 1. So again, our base. Now whenever you have a fraction, you should put it in parentheses. Here's our exponent. And then it's equal to, and it's equal to this, 4. All right? So you have some U tries. All right? You can go ahead and stop the video, do the U tries, and then restart it. All right? So I'm going to do the U tries now. So again, we got our base, our exponent, and then what it's equal to. Our base, our exponent, and what it's equal to. Our base, our exponent, and then what it's equal to. Our base, our exponent, and then what it's equal to. All right? That's how easy that is to rewrite those in the different form. All right. Example 2. All right? This is where you evaluate them, and we're going to try evaluating these without the calculators. The only thing you really need the calculators for is to figure out what power that's going to be. So this is the way you do it without a calculator. All right, so what you do is you make it equal to x. All right, and then you rewrite it in exponential form. So it's base is 4, the exponent is x, and then equals 64. So now we just got to figure out 4 to what power equals 64. And if we use your calculators, you can just use your calculators by doing multiplication. So you can just put in there, if you do 4 times 4, and you get 16, and then you do times 4, and there's our 64. So it was 1, 2, 3, 4, so 4 to the third power would give us 64. And just to make sure, 4 to the third power, and there it is, 64. So we're going to rewrite this. 4 to the x equals 4 to the third power. And now we can see the bases are the same. So just set the exponents equal to each other. And we know that x equals 3. Or we know that the log base 4 of 64 is equal to 3. All right. Next one we got log base 4 of 2 equals x. All right. This one's a little harder. Our base is 4 again. This is our exponent. And it equals 2. Now here we have to be careful because we can't rewrite a 2 as a power of 4, but we can rewrite this power of 4 as a 2. All right, and what I mean is this. We can make this 4 into 2 to the second power. All right, so that's 4, and then there's our x still there, equals, and then 2, and when the 2, there's a first power. All right, now power to a power, we multiply. So we get 2 to the 2x equals 2 to the first. All right. Now we have our bases that's the same. All right. Once we have our bases are the same, we set the exponents equal to each other. So 2x equals 1. And now all we got to do is solve this. We would divide by 2, and we would get x equals 1/2. So the log base 4 of 2 is 1/2. All right, and then our last one. All right, so again, rewriting this. This is our base. We set it equal to x, so to the x power, and then equals 9. All right, so this is a trickier one in that now we got to make them figure out what 9 and 1/3, what base they would have that would be the same. And it is a 3, okay? Because this 1/3, we can really rewrite 1/3 as 3 to the negative 1 power. All right, so 3 to the negative 1 power. That's the same as 1/3 to the x. And then we can rewrite this 9 as 3 squared. Now, power to a power, we multiply. So it's 3 to the negative 1x equals 3 to the second. And now we got our bases are the same. So we just set our exponents equal to each other. Negative 1x equals 2. We divide by negative 1, and we get x equals negative 2. So the log of 1/3, the log base 1/3 of 9 is equal to -2. All right? All right. This next one, you need these to sort of solve problems. All right? And they're actually not real hard, but sometimes you got to make them to be the same bases. All right. So exponential and log functions are inverses. They undo each other. All right, just like multiplication and division, just like addition and subtraction. All right, so what happens is when we evaluate 10 log of 6, remember this log is log base 10. What happens is this 10 and the log cancel each other out, so it just leaves us with 6. All right, and that's only when the base and this is the same. So when this base and this base are the same, they cancel each other out. All right, so example B, we get simplify log base 2 of 8x. Now, here we have to make these bases be the same. So we got to rewrite this 8 as a power of 2. So we're going to rewrite it as log base 2, and 8 is 2 to the 3rd power. Now we got to write in that x. Didn't go anywhere. The only thing we did was rewrite 8 as 2 to the 3rd. Now that gives us log base 2 of 2 to the 3x. Now, when you have log and the base of the exponent's the same, these also cancel each other out, since that's a 2 and that's a 2, and it just leaves us with this. So we get 3x. All right? So now you have some U-tries. Go ahead and try doing the U-tries. See if you can do them on your own. All right? And then you can pause the video and then come back. All right, so here we go. We're going to do log base 2 of 64. So we got to figure out how to rewrite 64 as a power of 2. Because again, this base is 2, so we got to make this base of 2 so they cancel out. So again, I just take my calculator and I can do 2 to the 5th power. And that gives me 32. So then 2 to the 6th power is 64. All right. So it's 2 to the 6th power. So we're going to make this log base 2 of 2 to the 6th power. And then these cancel each other out. So it just leaves us with 6 for an answer. All right. The next one, we have a base of 4. We got to change the 16 into a 4. Now it's 1 over 16. So we would do this. Log base 4, 1 over 4 squared. Now we have to get this to the top. So again, we're going to put it in the wrong place. So we got to make the exponent negative. So it becomes log 4 of 4 to the -2. And now this is log 4 and that base is 4. Cancel out, leaves us with -2. All right. Now the next one, we got log 16 of 4. So this one, a little trickier because to make this a power of 4, make this into a 16. So this is a 16, so we want this to be a 16. Well, that's actually the square root of 16. Right? So we would write it as log 16 to the 1/2 power, right? Because 4 is the square root of 16, and 16 we can write as 16 to the 1/2 power, which means, remember, 16, right over here, all right? Remember, 16 to the 1/2 power is the same as the square root of 16. All right, that's what that 1/2 power means, square root. All right, so now they cancel out, and it just leaves me with 1/2. So I have my answer. All right, and here we go. We got these we're going to simplify. All right, so we got 7 to the log base 7 of x. Again, the log and the log, or the 7 is the base and the exponent, and this log, they cancel each other out, so it just leaves us with x. All right, we got log base 5 of 25, again, x. So we got to make this log base 5 of 5 squared to the x. All right, and then these will cancel out, so we get 2x. All right, and then The last one, we got log base 2 of 64 to the x power. All right. Again, we got to rewrite that 64 as a power of 2. We already saw that in 5. It's 2 to the 6th power. So this becomes log base 2 of 2 to the 6th power and then to the x. So we got log base 2 of 2 to the 6x, and they cancel out, and I get 6x as my answer. All right. So that is rewriting those. And that's it. All right, so that's it for the notes. So now what I want you to do is this. The top ones, you got to rewrite these in exponential form. The second part, you're evaluating these. And then this third part is where you're going to do that simplifying, which is what we just did. So all I want you to do is 1 to 21 odd. All right, that's all you're going to do is 1 to 21 odd. And that's it.